be to go over what the project goals were, an outline of the project tasks. Then we'll go through the findings for each task and then the overall findings for the project. We should have a little bit of time for Q&A, and then we have our next event scheduled as well with the ETCC. So I already introduced myself. I'll skip that. So for anyone who doesn't know about the Gas Emerging Technologies program, that's jointly funded by SoCalGas, Pacific Gas and Electric, and San Diego Gas and Electric. SoCalGas is the program administrator, and ICF is the prime contractor, and Lincus is one of their subs. It represents 11 million natural gas customers in California. It was launched in late 2021, and our research timeline is currently from 2022 to 2024. Okay, so getting into the project goals. The name of this project was Evaluation of Emerging Water Heating Technologies. The goal of the project was to research emerging water heating technologies through the lens of California's water heating market and the energy efficiency programs, so that the GET program had a better idea of what technologies to invest research dollars into. And when I say GET, if I didn't mention it, that stands for Gas Emerging Technologies. This particular project focused on 6 emerging technologies that are listed there. The first is a gas engine heat pump water heater in a commercial building. This is a vapor compression cycle that you would see in an electric heat pump, but instead of being run by electricity, it's run by a natural gas-fired internal combustion engine that creates that electricity it needs. The next technology is an absorption, so absorption heat pump water heater in a commercial setting. This uses a refrigeration cycle, just like a direct expansion, except for it's using ammonia and water, or lithium bromide and water, in order to pump the heat from the air into the water. So it is still a refrigeration cycle, but it is different than your typical heat pump cycle that you'd see in an air conditioner. The third technology is an adsorption heat pump water heater in a residential setting, which absorbs and desorbs in using something called a desiccant. The next 2 technologies are the same as the first 2, but they're in a combi application, and that just means that they can provide hot water for domestic hot water use and space heating use, but the technology remains the same. The last technology is a thermal compression heat pump combi system, and this can be used in both residential and commercial buildings. This uses a patented thermodynamic cycle in order to produce both hot and cold water, but we only looked at the hot water aspect of it in this study. So next, I'm just going to describe the tasks that we went through, and then we'll go into the task results. So as I mentioned, this project was done in parallel with another one on existing water heating technologies, and so they have some related tasks. The first project on the left side of the slide created a water heating technology table, which was essentially an expansion of our technology priority map for the program, which is abbreviated as TPM. The water heating technology table from that project was then used in this project to prioritize the emerging water heating technologies. And the outcome of that was to select a total of 6 emerging technologies for us to do some further research and study. Next, we interviewed subject matter experts, which is abbreviated as a SME. For both projects, a total of 16 SMEs were interviewed across both projects, and the results were analyzed. And we did additional analysis on the emerging technology manufacturer responses in this project. After the interviews were done, we did a deeper dive on those top 6 emerging technologies, and we looked into codes and standards that affect them, their applicability to zero net energy, and their applicability to disadvantaged communities, which would be abbreviated as DAC, and hard to reach markets. Next, we estimated high-level energy savings for each technology using the publicly available data that we could find. And the last thing we did was we used those energy savings calculations and we estimated the cost to install in order to calculate potential total resource cost and total system benefits for each technology. And you can see the acronym there, TRC, TSB. So now we're going to go into the findings on each task. So the first task was to take the 17 emerging water heating technologies from the water heating technology table and prioritize them in order to whittle them down to only 6 high priority technologies for which further study would be done. The prioritization that we went through, we used criteria related to number 1, energy efficiency and the GET program. Number 2, criteria related to end-use customers. Number 3, criteria related to the water heating market. And 4 would be criteria related to the regulatory environment. EE and program criteria that we looked at were an estimated simple payback and TRC, estimated market size for the technology, whether it had potential to complete a field or a lab study within the next 3 years. The reason for the 3 years is because our program is set to end at the end of 2024. The potential for a joint project with cooperation from other internal IOU programs. The reason for that is because that's in our one of our KPIs. The product efficiency level and the time to get the product commercialized. The customer considerations that we considered were if it had any added functionality when you use the emerging technology. So that would be something like a programmable water heater where you have a smartphone app now that you didn't have before. That'd be an example of an added functionality. The cost of the technology relative to the incumbent technologies. So if most people are just going to buy a tankless water heater, how much more does this new technology cost? The installation complexity and estimated costs based on the complexity. So if it's more complex than just replacing your existing water heater with something that's a drop-in replacement, that would be ranked lower than something that could just be drop-in. The market considerations were market readiness, technology brand equity or brand awareness among customers, and whether distributors and installers have confidence in the technology. So a technology that's being developed by a brand that's already known would have scored higher than a newer technology by a company that's not well known in the market. Market readiness, just so you are aware, that was a ranking of 1 to 5, with 1 being a pre-commercialized product and 5 being a product that's mature and already competitive in the water heating market. And then 4th, the regulatory considerations were whether testing standards existed for the product or were being developed, whether energy savings calculation methodologies and softwares or energy code compliance softwares existed or were being developed for the technology, and the risk that the technology would be made obsolete or prohibited by state or local codes. So an example of that is if the efficiency level is likely to be below a federal or state minimum efficiency level in the next coming code update cycles. The final 6 high priority technologies we ended with are the ones I introduced on the first slide, so I won't explain those. The table on the right shows the number of commercialized and pre-commercialized products for each technology, and this was as of 2022 when we finished this report. Things may have changed a little bit, but they haven't changed that much. But you'll see later on in the report, there is a manufacturer for the absorption gas heat pump water heater that is closer to having a product commercially available than they were when we finished this study. When we did our subject matter expert interviews, we made a point to interview the manufacturers of these technologies to get their feedback as well. So these are the findings from the subject matter expert interviews. We interviewed water heating experts to gather current market information about existing and emerging water heating technologies. They were recruited from the Hot Water Forum contact list, the list of midstream participating distributors, the South Coast AQMD's list of certified units for a couple of their rules, and through previous relationships that the GET team members had. When the task was finished, a total of 16 interviews were completed. You can see the breakdown of the type on the slide there. Each person was asked 32 questions. 16 were about drivers for high efficiency and emerging water heating drivers, and 16 were about barriers. This slide shows the key barriers and drivers that we found from the interviews. The top 3 from the overall survey with all 16 SMEs were 1, high initial cost of equipment, 2, lack of awareness by customers or installers about the equipment, and 3, a lack of trained installer and maintenance personnel. For the emerging technology manufacturers, the lack of awareness about their products and lack of training were more pronounced for those groups, which we would expect. And additionally, the emerging technology manufacturers also felt very strongly that the general adverse regulatory environment for gas is a significant barrier to adoption of their products. The drivers for participation were independent verification of performance of the new technologies, improved performance of the emerging technologies over the incumbents, and environmental compliance with things like AQMD regulations. So once we finished those interviews and selected those 6 technologies, we gathered some additional information on those 6 related specifically to the California energy efficiency market. The information was on codes and standards, zero net energy, and DAC HTR, which again is disadvantaged community or hard to reach market. It was important to us to find out what codes and standards in California could affect the emerging water heaters. So we looked at AQMD, Title 20, and Title 24. We found that AQMD limits the NOx emissions on all of the water heaters except the gas engine water heater. The gas engine water heater is under 50 horsepower, so that's why it's not currently regulated by AQMD. Title 24 regulates the minimum coefficient of performance, which is abbreviated as COP, of the gas engine water heater, the gas engine, and the gas engine COMI. Title 20 regulates the minimum uniform energy factor, or UEF, of the adsorption water heater. Neither Title 20 or Title 24 clearly regulate the absorption or thermal compression technology efficiencies, which we believe is a gap. The heat pump standards in Title 24 seem pretty specific to electric heat pump technologies because of the efficiency metrics they require and the test methods that they require. So that's why we think there is a gap in the Title 24 standards at the moment. We also wanted to see how zero net energy targets would impact these technologies. So we calculated the solar offset that would be required for each technology as a percentage of the building footprint. The thermal compression requires the least amount of solar offset, and the absorption water heater and combi require the most solar offset. These values were calculated using some estimated energy savings that we used during our prioritization in task 2. We also wanted to see if any of these technologies could participate in a DAC program, or a hard to reach customer site. In order to do that, we used the hard to reach, direct install, net to gross IDs in the CEDARS data to look at the measure costs for water heating that have participated in hard to reach customer sites. This was a proxy for DAC, since the DAC status is one of the qualifiers for hard to reach. And that was a mouthful. So if you're not in the EE industry, essentially we looked at other water heater measures that have been installed in disadvantaged community energy efficiency programs. We compared those water heater costs to the costs of the emerging technologies. We found that the adsorption heat pump water heater, that cost seems to be in line with the costs for condensing tankless water heaters that have participated in hard to reach direct install programs. So this water heater might be able to participate in the same types of DAC or hard to reach programs, which is pretty amazing for an emerging technology. We didn't have enough historical information on costs in multifamily or commercial markets in DAC and HTR to make conclusions on the other technologies. Moving on to the next task, we took the 6 high priority technologies and we found performance data from field studies or manufacturers, and we put it into calculations to determine a high level energy savings for each technology. So what you're seeing here again is very high level. All of these technologies except the absorption unit have coefficient of performance data that's a function of the outside air temperature. So that means that the efficiency of the unit changes as the outside air temperature changes. We used the existing Deere water heater calculator, which already has hourly inputs and outputs, and we modified the calculation methodology so that the COP in each hour is based on the outside air temperature. And from there, the hourly energy use in the calculator is based on the hourly water heating load and the hourly COP. In the combination systems, we needed the hourly water heating and the hourly space heating loads, which the water heating calculator doesn't have space heating loads. So we got the hourly heating loads from Deere models and we added those space heating loads to the total load. So the load would be water heating plus space heating, and then you use the COP to determine what's the actual energy use in that hour. The adsorption water heater was not rated using a COP, it was rated using a uniform energy factor. And that's because the uniform energy factor is the standard efficiency value that's used for single family home water heaters. It is abbreviated as UEF. In the Deere water heating calculator, this UEF value is converted into something called a recovery efficiency value. So for the adsorption water heater, we converted the manufacturer provided UEF into an equivalent recovery efficiency. We plugged that recovery efficiency into the calculator and we didn't change anything else. So that means that there is no change in the unit efficiency with outside air temperature for that unit in our calculations. We got this data that we used from field studies by NEA, which is the Northeastern Energy Alliance. Can't remember exactly what that stands for. But we got that for the gas engine and the absorption units. There was some other third-party data available for a different manufacturer of the absorption unit, but it was in a residential setting, and it wasn't as easy to translate into COP versus outside air temperature. So we decided to just use the NEA data in these calculations. The adsorption UEF value came from the manufacturer directly. The thermal compression COP was a single COP at a single outside air temperature from a Department of Energy study. So we estimated what the COP as a function of outside air temperature would be using the COP data we had for the other units. So the savings for both the adsorption and the thermal compression units should be taken with a grain of salt because they're not using lab or field verified efficiency values. We decided to do a total of 8 calculations for 6 technologies so we could calculate savings for the same technology in 2 different building types. So 2 calculations were done for absorption combination in a small office and in a nursing home. And we did 2 calculations for thermal compression in a fast food restaurant and a single family home. We chose the building types that we used by looking at the Deere weights for climate zones and building types, and then looking at the total heating loads from the Deere models and the water heating calculator to see which buildings were the right size as far as the capacity that's needed for each technology. That is too complex to explain with a few slides. So if you want some more detailed info on that, I would encourage you to check out the report because it has a lot more detail in the report. So you can see that the thermal compression unit has the highest percentage of energy savings. and the absorption water heater and combi have the lowest percent of energy savings. Um, the adsorption savings of 32%, although it seems low, is a pretty good for a single family home water heater compared to some of the other things that we offer incentives on currently. Once we got those high level energy savings values, we calculated the total resource costs and total system benefits. So total resource cost is TRC, total system benefit is TSB. If you hear me use those acronyms, that's what they mean. If you don't know what those are, TRC is a cost effectiveness metric for energy efficiency programs, similar to return on investment. And TSB is a measure of the overall benefits of energy savings to the state of California over several years. We got standard measure costs for the incumbent boilers or water heaters from existing measure packages. And we got the cost for the actual emerging technologies from manufacturers directly or from studies. The installation configurations affect the measure costs and the effective useful life in these calculations. So for example, you could install an absorption unit alongside an existing boiler that would reduce your overall measure cost because you don't have to replace that boiler, but it might limit your effective useful life because the existing boiler might be limited to 5 years instead of 15. The other thing you could do is install it alongside brand new boilers, which would increase your total measure costs because you have to replace those boilers, but it would also increase your measure life to 15 years. In these calculations, we assumed all of these units were installed alongside new condensing boilers so that they could maximize their operating time and maximize their useful life to that 15 years. We calculated a TRC without incentives and with incentives equal to 100% of the measure cost so that we could get a full range of potential TRC values. The thermal compression combi unit in a fast food restaurant has the best TRC at 3.17. So higher TRCs are better if you don't know that metric. But this needs to be taken with a grain of salt because the savings there were again based on a single efficiency point provided by the manufacturer. The lowest TRCs for the absorption combi in an office building. The other TRCs for that unit of 0.88 at the top, which was in an assembly building, and 0.62 for a nursing home, indicate to us that the sizing of the absorption unit needs to be done properly so that you can maximize the absorption unit's operating hours, which maximizes its energy reduction and minimizes the cost per capacity of the system. The adsorption water heater has a TRC less than 1, which we typically don't like to have TRCs less than 1, but those are not uncommon for single family homes based upon some other analysis we did of CEDAR's data in single family homes for other measures. The same goes for the thermal compression combi in a single family home. Its TRC is less than 1, but it's also worth noting that when we did the energy savings analysis, and selected the buildings to do the analysis in, we were not trying to maximize the operating hours, but pick a building type that had the right heating load for that particular technology. If we did further study on this, one thing we might do is analyze the number of hours in a year where a building's load is above a certain threshold and choose buildings based on both the maximum capacity that they need and the number of hours above a certain capacity. So then we're just going to discuss the findings for each technology. First up is the gas engine heat pump water heater. We ultimately didn't recommend this for further study. It didn't trigger AQMD at this time, and it can modulate down to the actual hot water load, which were both really great pros for this. It also had TRCs that were close to 1 and the highest TSB among all the technologies, which are also important factors. However, this system had the highest overall upfront cost, and there is additional maintenance required for the gas engine that will eat into some of the utility cost savings. The additional maintenance costs we didn't have, so we did not put that into the TRC cost, but it is going to impact customer decisions to install this. It's mostly installed where electrical service is unreliable or hard to get, so we didn't feel like it had a very large market share in California at this time. And further, if its market share did increase, although it's not currently regulated by AQMD, there is a risk that it could be. So those are the reasons we didn't decide to go forward with further testing. Next up, with the absorption heat pump water heater in Combi, this system was recommended for further study. It's applicable to many commercial buildings as well as multifamily buildings. The TRC and water heating only application is 1.02. There was a need to get more data, and there was an opportunity for our program to gather more third-party data for this unit. There's already an existing measure package for this unit in multifamily. The CPUC requested more data to be used to update that measure package when that data is available. And there have been no third-party studies of the water source version of this unit, and we didn't know of any plans by other organizations to study it. We found that for some of our other technologies we wanted to test, that manufacturers are already working with some other entities to test their products. And even though we wanted to do some testing, the manufacturer may not have been interested in having us test their product because sometimes they have to make a brand new prototype for that, and they don't see the value in doing additional testing for the expense of their prototype. So in this case, one of the manufacturers for this product was very easy to work with. They were willing to let us purchase some units to test in the field. And so we thought that that was a good opportunity for us to be able to fill the gaps that exist and to be able to do it in California. The drawback of this technology is that the only unit that's currently commercially available, it can't modulate to the actual water heating load, and it can have low TRCs, as you saw before. And that has been a little bit of a struggle as we try to get our field study set up. However, there is a second unit from a different manufacturer which can modulate, and that unit is expected to be out later this year, commercially available, and we're hoping to be able to do field tests and lab tests on that second unit as well. We are currently recruiting sites to field test both manufacturers' units, and as I said, we're planning to test at least one of the units in the lab, if not both. Moving on to the adsorption unit, this was also recommended for further study. It's being designed as a single family drop-in replacement with a similar cost to tankless condensing units, which have seen increased participation in EE programs over the last few years. It needs some third-party testing, and it can potentially participate in a DAC program. However, it's not commercially available at this time, and there's no planned launch date. The TRC is low, but that's not uncommon for a single family, so we feel this is a good candidate for future studies. The manufacturer is currently working with another organization to get performance data, so the GT program will stay in contact with them to see when we could do some testing to complement what other organizations are doing. And lastly, the thermal compression combi unit. This unit was also recommended for future study. It requires the least amount of solar offset. It's hydrogen ready, which is a great bonus, and it has a potentially really great TRC of 3.17. And again, this could be impacted by the third-party performance data or some more robust cost data. It also needs some third-party testing, which our program could provide. The TRC in single family is low, and the cost in single family is high, but this can also replace water heating and space heating. So the TRC could increase if the baseline cost for space heating in a single family is also considered. This product has the most uncertainty in the energy savings due to the fact that that COP value is only at 1 point and comes from the manufacturer, but we feel that it is worth investigating further. So we'll move on to just the overall project findings that aren't technology specific. The first overall finding is that most of these emerging technologies only have a single manufacturer. The absorption unit has 4, and the adsorption unit has 2 when you include all of the non-US manufacturers. The AQMD standards impact all of the emerging technologies except for the gas engine system, because again, it's under 50 horsepower. And what the standards do in AQMD is they limit the NOx output of the units. If the market share of the gas engine unit were to increase, we think that there's a risk that this too could be regulated by AQMD at some point. Title 24 impacts the efficiency requirements for the gas engine unit, and Title 20 impacts the efficiency for the adsorption unit. And there appears to be a gap in the efficiency regulations for the absorption and thermal compression units. The range of savings for these technologies is between 26 to 49%, with TRC values that range from 0.21 to 3.17. The emerging technologies have the same barriers as existing technologies, with the added barrier of an adverse regulatory environment. The existing energy savings calculation tools that we have, which are DEER models using eQuest and the DEER water heating calculator, do not currently have the ability to model gas-fired heat pumps or combination heat pump, gas-fired heat pump systems. The DEER eQuest models do not appear to have the ability to model a gas-fired heat pump, and they don't have domestic hot water heating loads in there. The DEER water heating calculator doesn't have gas heat pumps as a technology option in the tool. A quick disclaimer, this study was finalized in 2022, and we weren't able to fully investigate if anything has changed from the DEER eQuest models to the DEER Energy Plus models that are now available. We heard that there is a gas absorption module being developed for Energy Plus, but we don't have confirmation on if or when that will be released, and we don't know how it would fit into the new DEER Energy Plus models. So there's a potential that that problem could be solved, but we don't have enough details on it to say for sure yet.
Crystal, just one quick, yeah, someone just mentioned it. It's been released.
Okay, the module for Energy Plus?
It's within Energy Plus, yeah.
Okay.
Yeah, that's correct. It got merged in a few months ago. Just as a
Okay.
heads up.
Excellent. Good to know. Yeah, as I said, we finished this last year, so things have changed since then. So that's good news. Moving on, there's not standardized third-party performance data for these technologies. So that's not to say there isn't performance data. It's just not in some kind of a standardized format. That will be needed in the future for these products to go into EE programs. So to expound on that a little bit, there are testing standards for these types of heaters, but the testing standards don't always give you a full performance curve through the range of the expected outside air temperatures. And because the efficiency changes with outside air temperature, that's an important thing to have when you're doing modeling. And so having some kind of a standardized performance curve test setup or test methodology is something that we will probably be needing to have. The data used in this study was from field studies or manufacturers if field studies weren't available. And even, again, that field study data is not done using a standardized testing approach. And of the 6 technologies studied, 4 were recommended for further study. There are recommendations to perform follow-up lab work and field work for the 4 technologies that are listed here. This lab and field work would focus on gathering those performance curves, CO2 load shapes, the different installation configurations, and cost data. The performance curves in the lab would ideally be done using a standardized approach. GTI did provide us some information on what they would recommend as a standardized approach, so we do have that. The CO2 load shapes are so that we can compare the source CO2 on an hourly basis for gas-fired heat pump water heaters to the source CO2 for electric heat pump water heaters. What we found is that the comparisons between a gas-fired and an electric heat pump water heater are using average grid CO2 intensity, but domestic hot water and especially space heating may be used more often when the sun is not shining and when the grid CO2 is higher than what the average is. So that's why we want to investigate that. We found that there are a few different installation configurations for these units, which have cost and effective useful life implications. So we need to gather some more information about those different configurations and costs. And lastly, in general, we don't have much cost data, which was noted by us as a gap by GTI when we spoke to them about these. So that's another thing that we're going to be gathering through our lab, or mostly through our fieldwork. Okay, the other recommendations besides the lab and fieldwork are to coordinate with workforce education and training to support training for installers and maintenance personnel on the new technologies. We also recommend that some customer education be created that shows customers the fuel cost savings, the energy savings, and even the CO2 savings when using emerging technologies. This will create more awareness of these products, and the CO2 savings education is expected to create a more positive view of the emerging technologies. And lastly, we think the program should support development of modeling or calculation tools so that the gas-fired heat pumps can be properly modeled in a water heating only and a combi situation going forward. So now I'll open it up to some Q&A, and just so you know, I will be presenting on the gas absorption heat pump water heaters at the ET Summit on August 23rd, and August 28th, 2023. If you want to know more about those, please feel free to register and join. And I'm in presentation mode, so if we want to see my slides, I will need somebody, maybe Alfredo, to read comments to me. I cannot see them.
Definitely. Thank you for that, Crystal. There was one question at the beginning. Is the list of subject matter experts that you interviewed confidential?
I believe it is, yes. We told them that we wouldn't release their information to others.
Perfect. And then there's a question after that. The energy savings, therms per year, and percentages don't seem to line up. Am I reading it wrong? I believe that was in reference to slide 15, potentially. Wherever you had the savings laid out.
This one? No.
I
maybe
think it was the one before that. Yes. That was the question. So I'm not sure if there's any more information.
That could be the savings per year is the percentage is based on what the total energy usage was. So where you see the 44% with 11,000 therms savings, that means that the baseline energy usage here was probably lower as compared to perhaps this one, if that's the question. Maybe that person could take themselves off mute if they have maybe more clarification.
Yeah, that answers it. They were serving different loads then.
Yes.
Okay.
Yeah, that's a good point. Maybe I should have put the baseline in there.
And Crystal, also, I think that there's a mix of not only different end use and sites, but also different types of segments. So there's residential in here as well as commercial. So the baselines will be significantly different, and it'll appear weird here.
Yeah, so I probably should have added for the first four the type of building, but yeah, the type of building affects how much energy it consumes with the incumbent technology, and that would be very different, as Eric said. So that's the reason.
Perfect. That was all the questions in the chat. So if anybody else has questions, feel free to to either type them in chat or take yourself off mute.
I did want to add a clarification, just in case there was a statement, or it was noted that, there was pre-commercialized and commercialized products, but the pre-commercialized were not in like an alpha sort of pre-commercialized state, which would be more of a research and development type of product. So I just wanted to highlight that. We were looking more at equipment that was close to being commercialized. In fact, I think one of them in particular, it's been threatening to be commercialized for a few years now. So in case anybody was wondering why an emerging technology program was dabbling in that side, just wanted to clarify that.
Yeah, thanks for that, Eric.
This is Alejandro from GTI Energy.
Hi.
I believe I heard a comment about a lack of a method of test for rating gas heat pumps. I don't know if I heard that correctly, but just so you know, there is a method of test, ANSI Z2040.4 for gas heat pump. One of the I guess limitations with that method of test is only applicable for space heating applications only, and does not necessarily cover the overall spectrum, right? If you want to rate the system as for water heating in the summer times and all that, but there is a method of test at this point for that matter. Then there's also that results into an annual seasonal efficiency. However, when it comes to other applications such as just water heating, things changed. There's also, ASHRAE 118.1 and 118.2 that addresses, single point efficiencies and capacities for residential, commercial, unitary, and split heat pump systems as well. However, those method of test does not give you an annual result, given that water heating loads could be all over the place, and it also depends on the ambient temperatures. So I just wanted to bring that up.
Yeah, thanks for that clarification. I might have misspoke. I was aware there was a method of test. I believe we spoke with Alex Fryland, and he seemed to indicate that the test method, the ANSI Z 40 point something, I can't remember all the numbers, I'm sorry, didn't provide you with the efficiencies at several different outside air temperatures. Is that incorrect?
It does provide you, it actually executes over 5 ambient temperatures, but those are only for space heating. That was my point. So if you were to have an annual for space and water heating and all that, there's no such method of test to give you a annual number to say, oh, the system annually in this region for space and water heating is this efficiency. But there is a method of test for just like air source heat pumps, right? It's just PF of 9 or whatever. It's similar to that, but for gas heat pump systems.
Okay. We did notice on the spec sheets for some of the units that the COP that they only listed a single COP value when they used that ANSI test. So you're saying that they would have had to do the test at those different ambient temperatures? Maybe they just didn't report it on their spec sheet?
Correct. Yes. They report an FUE, right? So that will be the end result calculation. Now, some of these manufacturers that I believe you mentioned in this presentation, sometimes they just might show in a specific 1 point. So there's that. And
that's what I recall was
the full testing, and then actually reported the seasonal COP or annual utilization from the, I believe it's about 8 points. So it depends if the system modulates or not. So
Mhm.
there's all those tests.
Okay. Thank you for that info. That's good for me to know. Any other questions? Comments?
Oh yeah, I have a question. Did you, as part of this presentation, you was included any manufacturers outside of US?
No, we didn't include
like North
anything
America?
outside. Are you talking
What-
about the
Canada?
unit that's in Canada? No, we didn't actually have data for that unit that we could find.
Okay. All right.
But
Just,
if
you know.
they have some, we'd love to know where it is.
Yeah. So yeah, there's a company bringing some technologies from China. There's a lot of utilities with a lot of interest for residential and commercial size units.
Mhm.
Yeah, so you might, yeah, I can follow up with some of that information. So you're aware of what these companies are,
Okay, yeah. Would you mind if I followed up with you after this meeting?
Sure, yeah, no problem.
Okay, let me do that. Yeah, we did check with a few manufacturers and, one of them told us that they're working with a manufacturer rep and they couldn't give us any information.
Okay.
All right. Well, if you guys have any other questions, you can always email Alfredo here at this email. I believe that these slides will be sent out in the next couple of days. So if you think of something and want to ask, feel free to contact Alfredo and then he'll reach out to me.
Perfect. Thank you, Crystal. And thank you everybody else for showing up and attending. We really appreciate it. If there's any questions, feel free to reach out.
All right. Thanks, everybody.
Thank you.
Thank you, everybody.
Thank you. Well done.
Bye.
Thank you.
Thank you.
Bye-bye.